So in general, oceanographers study the physics, the chemistry, and the biology of the sea with the goal of trying to understand how the ocean works and also how the ocean is changing. And I'm a biogeochemical oceanographer, so I'm interested in understanding the chemistry of the ocean. So particularly how our climate affects the chemistry of the ocean, and how in turn the chemistry of the ocean affects our climate. So broadly, my research is focused on understanding the relationships between biogeochemical fluxes, so for example carbon and nutrients, and productivity in the ocean, which has significant implications for climate. I do a lot of work in the Southern Ocean, which is the most important oceanic region for climate because it stores more heat and more carbon dioxide than anywhere else. It's also the region where the Atlantic, Indian and Pacific Oceans meet and is highly sensitive to global warming. So a major motivation for my research is to develop expectations for how the chemistry and biology of this important region might change in the future. Well, there's a connection of my research to climate and climate change. Basically, it's imperative that we understand how our oceans function now and how they're changing if we're going to develop and implement good policies to protect them, while at the same time still being able to use them for resources such as food. And this is actually directly in line with the government's recently launched Operation Pakisa, which is an initiative aimed at growing South Africa's economy using the oceans, but doing it in a sustainable way. I currently supervise 10 postgraduate students, all of whom are working on research projects that involve intense field work, so they've all spent time at sea. The SA Gullis 2 is an incredible resource for us. She's absolutely state-of-the-art, equipped with state-of-the-art instrumentation, and she can go into oceanic regions that most other research vessels can't. So for example, the sea ice zone of the Southern Ocean in winter. It's hard work. When the vessel's at sea, she works 24 hours a day, and so we work 24 hours a day as well. We collect various types of samples, we deploy instrumentation over the side, we run experiments, we work in the ship's labs, and we analyze data. Going to sea with my students is something that I particularly enjoy because it's only when they see how things work synergistically in the environment that they really come to understand the system that they're researching. I think I realized while I was working on my honours thesis, which involved reconstructing past ocean temperatures using a 10,000-year-old coral from the Great Barrier Reef, that I really enjoy the process of research. Asking a question, designing experiments to address that question, collecting data in the field and in the lab, and then interpreting those data, which inevitably leads to more questions. I've been working to establish a new marine biogeochemistry lab at UCT that will be equipped with novel and state-of-the-art instrumentation to allow us to address oceanic questions at much higher resolution. And I think that this shows UCT and the NRF's commitment to the future of oceanic research in South Africa. And I know that it will allow me to take my research to a whole new level.